Good morning. This is Professor Gardetto with a mini video on homework number 19. Welcome to week 7, by the way. Only 2 more weeks left of the class. Let me preview the assignment here and show you what you're going to be seeing. Little new notation that you haven't seen before. It's going to look like an exponent, but really not really be an exponent. It's called an inverse. Okay, that this right here is a function. We've seen functions before. Um, that m of x really acts like a y. Okay, so y. Remember, y equals mx plus b. Well, this is a y equals x minus 4. Okay. So that's just an equation, or you can think of it as a function. Don't really worry about where it says 1 to 1. So what we want to do is we want to find what the inverse of this function is. The way to write the inverse is using this little -1, which is an exponent. But it's just notation that's what the inverse is. We don't write out the word inverse. We write this little -1 above the variable, like it is an exponent. Like for the inverse for y, the inverse would be y raised to the -1 power. Okay, that's just a notation for the inverse. So that's going to be equal to the inverse. Okay, so let's talk about what inverse is. Inverse means the opposite of the function. So what we do for the inverse, and you think of the word inverse, you might think of the word invert. If you inverted something, you would switch them around. So when you have to find the inverse, we go through. There's 2 steps. Okay, step 1 is to switch the x's and the y's. Switch the x's and the y's. So if you don't see a y, this is the y. Okay, that is the y. So that's why I wrote it out like this. I wrote the m of x equal to y. So I switch the x's and the y's. So where I see the y, I'm going to put the x. And where I see the x, I'm going to put a y. That's a pretty easy first step. Second step, remember there's only 2 steps to find the inverse. First step, switch the x's and the y's. Second step, solve for y. Solve for y. Because you're going to have to get y by itself. So we solve for y here. We want to get y by itself. We add 4 to both sides. And that is the way to find the inverse. That is the inverse. The inverse will be what you have when you solve for y. When you solve for y, on the other side will be the inverse. So in this case, it's going to want you just to write what the right-hand side is. So that would just be x plus 4. Okay. Let's try another one. Okay. First step, switch the x's and the y's. Okay, well, if you don't see a y, this right here is equal to y. So if we switch the x's and the y's, that's x equals 5y plus 1. And now we solve for y. Subtract 1, divide by 5. I can do that at one time. Subtract 1, divide by 5. That's what y is going to be equal to. And that's going to be the inverse. So this is what we put in the box here. They already have the inverse already written out for you. Okay. Let's try one more. All right. So we have a of x equals cubed root of x plus 4. So a of x is y. So it's y equals cubed root of x plus 4. So let's see. We switch the x's and the y's. Don't forget to do that step. Switch the x's and the y's. We subtract 4. So we end up with the cubed root of y. And now, do we remember how to get rid of a cubed root? Think about it. How do you get rid of a cubed root? And if you're thinking you cube it, you're correct. You cube it, cube both sides. Cube both sides. The cube and the cube root are gone. And we end up with x minus 4 cubed. And that's how to find your inverse. Okay, get rid of a cubed root, we cube both sides. Okay, so that's what's going to be. It's going to look like that for the few problems up through, I think, number 10. And then starting on 11, it changes to exponential functions. So we have not done this before. We have not solved for a exponent. So let me show you how to solve for an exponent. Tomorrow we're going to talk about a topic called logarithms. We don't need logarithms if we can make the bases the same. So let's just, I'm going to use some vocabulary here that I want to make sure you guys understand. If I say base, I mean big number, right? The big number is the base. The small number is the exponent. So in this case, 3 to the x, the base is 3. 9 is 9 to the first power, the base is 9. Now, this one here is a pretty simple one. You might be able to solve this in your head. The solution of 3 to the x equals 9 is, yes, it's 2. 3 to the second power is equal to 9, and that's what we put there. Okay, but there's a if-then statement that I'd like to talk about. Okay, so if a to the x equals a to the y, that means if the bases are the same, if you have the bases the same on either side of an equation, then these two exponents have to be the same. So even though we could solve this in our head, and so we know that x is equal to 2 here, the reason why x is equal to 2 is because 3 to the x equals, think about how we can write 9 as a base 3. How do we write 9 as a base 3? Well, we write 9 as a base 3 by writing 9 as 3 squared. So since the bases are the same, the exponents are the same. So that's why x is equal to 2. Okay, let's look at another one. Okay, so this one here has a negative exponent. It's okay, it doesn't matter. We want to make the bases the same. Well, 3 can't be written any smaller. So on the left-hand side, we're kind of stuck. We have to leave it as 3 to the negative x. 81, though, 81 can be written as a base 3. Think about 81. I'm going to break 81, two numbers, and then multiply to 81, 9 times 9. And then 9 is 3 times 3. So 81 is 4 3s multiplied together. 4 3s multiplied together. So that would be 3 to the fourth power. So we accomplished our goal here was to make the bases the same, because if we can't make the bases the same, we can't solve the exponential without logarithms. And we do not want to talk about logarithms today. So those bases are the same. So now negative x equals 4. And then we have to solve for x. So if negative x equals 4, x equals negative 4. Okay, let's try one more. Okay, 5 to the 4x minus 9 equals 125. Okay, so it's kind of a hint here that they use 5 as the base on the one side because 5 can't be written any smaller. So this 4x minus 9 is the exponent. So that tells you that you better be able to write 125. In order to use this method, b to the x equals b to the y implies x equals y. In order to use this method, we have to make the bases the same. So we need to make 125 a base 5. So there's got to be a number of 5s that multiply to get 125. So if you think about that in your head, 5 times 5, 5 times 5, 25, 25 times 5, 125. So this is 5 to the third. Okay, and this is always going to happen on this homework assignment, homework 19. You're going to be able to make the bases the same. That's not going to be the case tomorrow. Okay, so if we have this, then we write, we have the bases the same, so we know now the exponents are the same, and now we have a little equation to solve, which isn't too difficult. 4x minus 9, that's a huge minus 9 because I got my mouse slipped on me. So 4x equals 12, and divide by 4, and so x equals 3. Okay, that should get you through most of homework number 19. Make sure to view the online lecture this morning, either in person or I'll record it and put it on conference Zoom.